So this is our farm. This is a shot from a couple of years ago. This is about 80% of our fields. So we are in Sebastopol, California, which is about an hour and a half north of the Golden Gate Bridge of San Francisco. We are on 8 acres down in a low valley bottom. We are in wine country, and you can see our neighbor up around the edge there is a vineyard. It's a conventional Chardonnay vineyard. It's about 140 acres. Our property, 8 acres, about 3 of that is our vegetable production, 2.5 to 3. It's intensive. We go year-round, although things definitely do slow down in the winter. We don't get as cold as you all here, but we do get chilly. It was 27 degrees when we left yesterday morning. So we do definitely have frosts in the winter. About 40% of our produce goes to a CSA, and we originally started out as a CSA farm. We love the CSA. About 50% of our produce goes to our farmers markets. Have one happening tomorrow and one on Sunday, so those go year-round. And then the last little 10% goes primarily to some local restaurants and also our local food hub. So except for the local food hub, which sends things down to San Francisco, about 97% of our produce stays within 15 miles of our farm, and we're really proud of that fact. We have a close connection with our community. We love our community and feeding our community. Next slide.
So just the real basics, which we all know, but soil is basically air, water, and mineral. And it's that small little percent, the humic acid, which is the life, the biology, the real, it's what makes it not a sand dune or a beach, but soil that we can grow food from. So next. And just a quick quote, even though this is the polar opposite of Utah's desert climate, every time you take a step in a mature Oregon forest, your foot is being supported on the backs of 16,000 invertebrates with an average total of 120,000 legs. And I love this quote because it's a really good visual for understanding how much life is in healthy soil. And that's just the invertebrates with legs, right? And those are just every footfall when you're walking through the forest. So, next. So really important to understand what truly healthy biological soil can look like. And yet, despite that, it's well known that tillage massively disturbs and disrupts soil, especially soil biology, but also the other properties of soil as well. So one of the major ways it reduces organic matter level in soils is very active tillage is breaking up the aggregates of soil. And this is plowing, tilling, disking, and it makes smaller and smaller aggregates. You have greater surface area, which means you have more release of carbon and nitrogen from the soil. It mixes with the oxygen being injected by the machinery to create carbon dioxide and nitrous oxide, 2 of the most potent greenhouse gases. And yet, as a farmer, 2 things you need most in your soil are nitrogen for plant growth and carbon for soil structure. So the very active tillage is removing the 2 things you need most, and others, and making greenhouse gas emissions out of them. Next. So therefore, there's a whole second aspect of tillage then, and this is a great quote because again, it's our USDA, which they're often slow to catch on to good science. But tilling the soil is the equivalent of an earthquake, hurricane, tornado, and forest fire occurring simultaneously in the world of soil organisms. Simply stated, tillage is bad for the soil.
I like to think about when you're taking those aggregates and you're breaking them up through your tillage via either a John Deere or a horse and plow or just even double digging or something like that. You're breaking down those aggregates, and so you're increasing the surface area compared to the volume. That's how you're getting more of the volatilization, like he was talking about, of the nitrogen and carbon, but you're also completely destroying the ecosystems for the biology down there, and that's where we get this.
Next. So one brief example, and there's many, but I love looking at this old USDA study in Tennessee. You got no-till and moldboard plow. Look at the erosion total per acre per year under plowing. It's about 700 times more erosion in the moldboard plow system than the no-till system for same crops, same soil types, and same valley bottom in Tennessee. Now, honestly, that erosion amount per acre per year, it's about 1/13 of an inch. It's very minor. And it was half the national average when the study was done. The national average was over 9,500 pounds of soil loss per acre per year. So often you can't even see the soil that you're losing. But to know that every pass with the tillage equipment is leaving your soil vulnerable to erosion by wind or water is important. To know that we can farm 700 years and have the same amount of soil loss with a no-till system as 1 year in a tillage system. So, critical for Utah, and also critical for our desert Central Valley of California, every single pass of tillage equipment can remove the equivalent of a 1/4 inch of rainfall from your soil. That's important to think about when we go out there to prep the fields and get them ready. Next. And globally, we've already lost about 2/3 of planetary soil carbon from our agricultural soils. That's next, actually. So that can be seen in our US pre-cultivation topsoils. We're ranked about 6–10% organic matter. And honestly, organic matter is about 57% carbon. Just to give you an idea, it's about half carbon and half other components for that organic matter. Today, we're between 0 and 3% organic matter in our nation. Most of our organic matter in our biology has been destroyed and blown off and put up there where we don't need it or out in the oceans. And you have things like the UN and EU came together looking at a large study, many different, like a couple thousand studies together in a meta-study, wondering how do we start mitigating greenhouse gas emissions? And they found that agriculture has the greatest capacity to mitigate at the cheapest cost of euro per ton equivalent. And where did all that capacity come from for cheaper, more efficient mitigation? 89% of that potential came from better soil management. We often think about rice paddies and sheep and cattle and their methane farts, but honestly, it's better soil management. That's where the agriculture's mitigation potential comes from, because we've already lost so much of our soil carbon. All we have to do is just put it back to where it used to be, and we can have such healthier soil and healthier food and start feeding ourselves true nutrition.
And so definitely good for our climate, but just also good for our farming, increasing that soil carbon in our soil so that we can farm better, healthier, more nutrient-dense food. So on our farm, when we started out, and in our workshop, I'm actually going to show we're going to show some history slides. When we started farming, you look at this. Well, this was all tractor done and tractor formed beds. It doesn't look so beautiful. We started out with a soil organic matter of 2.4%, which has got a soil carbon of 1.4%. As we changed our processes into permanent beds, where we were no longer tilling, we were able to increase our soil organic matter by 1 percentage point a year. This has been replicated several times by other farms who are replicating some of our practices, so that starting in 2013, we started to have a soil organic matter 8%, and at these days, it's 10 to 12% depending upon the field. Now remember what Paul said, that they believed that our fertile land used to have soil organic matter of 6 to 10%. We found that this 8 to 11% is a really beautiful place to be in. Guess what? I think Mother Nature knew what she was doing. There's a really good balance where you've got your biology and what you need for a good, healthy ecosystem of growing plants and growing food in that area. So we need to get our soils up there, and then the growing food is much easier.
Next again.
Transition?
So actually, go ahead, hon.
I guess these got screwed up a little bit, pardon not me, but we'll work our way through it. Managing for soil health, we actually like doing these slides. These are from the USDA, and we think about how we manage our soil via these principles, but I also know many larger scale grain and animal producers use these same principles. So when somebody comes to us, be they a gardener or a larger scale farmer, we always try and go back to these principles. So the first one, you guys know these, is disturb the soil as little as possible. Keep living plants in the soil as often as possible. Grow as many different species of plants as practical. Keep the soil covered all the time, and incorporate animals. Next.
Converting Macintosh to PowerPoint. Sorry.
Okay, so let's go over the first one. Next. We just talked about, why do we not want to disturb the soil? We don't want to break up the biology that the plants are feeding the whole soil food web that's happening there. Next. This is on a friend of ours' farm up in the foothills of the Sierra at about 2,000 feet. They had put together a no-till farm that worked really, really well on their parents' property. Then they went and bought 10 acres and started again. This is 6 months in. So you can see they've got a very clay-based soil. You can see there's some compost they added at the top, but look how much life there is. And they've only had maybe 5 rotations of crops through here. So this is what we want to see, the fungi, the earthworms, lots of life happening.
But that was 5 rotations in their first year so far, right? We're talking about lots of crops back to back.
This is us. You're looking at the root stem of an escarole plant. We cut this. Look at all that life, all the earthworms in there. The last thing I want to do is come through there with a rototiller or a plow, right? So now the second principle, keep living plants in the soil as often as possible. Why? Got this from Christy Jones. Your 4 basic steps to draw down CO2 from the atmosphere into the soil and just to feed the life in the soil. First, photosynthesis. So for anybody who isn't familiar with this, photosynthesis, remember your middle school biology. Your plants are taking in the CO2, they're breaking off the C, they're releasing the O2 for us to breathe again. That's C, carbon, they're then turning into glucose, your most basic building block of life. Then they're resynthesizing that glucose into a myriad of other carbon-based products, right? Everything from amino acids and proteins and waxes and fats and more complicated sugars. Then you've got exudation. I've heard numbers as low as 30%, as high as 80% of the products of photosynthesis, all those carbon-based products that those plants are creating, they are not using for their own growth and development, but what are they doing? They're feeding their community. They're feeding all the microbes, and that is the process of humification. And so, love this, got this from Ray Archuleta. This is in a Petri dish, but what we're looking at here is a root hair, and you're looking at, he called it liquid sun, but these are just sugars. This is liquid sun and the carbon-based products being pushed out through those root hairs to feed first the bacteria and also the fungi in the soil that then help feed the rest of the soil food web. And this is from NRCS. So what do we have? We have our plants both decomposing, creating organic matter, as well as feeding your fungi and bacteria, which are going to feed your larger and larger and larger soil organisms. This is what we want. And as we've looked at our soil organic matter on our farm, a lot of people have actually asked us, has your increase in soil organic matter come only from your compost? And we did some back of the napkin calculations. We think that only about 1/3 of it came from the compost applications. Most of it came from this.
And so this is actually hit it again because this is a video, but this actually is soil from our neighbor, which was a 140-acre conventional vineyard. And I went out there, this was what?
October,
not too long ago. And funny, the video is a little bit slow and jerky. But you can watch, this is vineyard soil. It was a hard clump, about 6 or 8 inches down, right at the plow zone where you start to hit hard pan. Actually hurt my wrist a bit digging into it and chipping it. But this is just the first few minutes we put the clod in. It was a rock hard clod of soil that is completely dissolving and breaking apart in just the first few seconds and few minutes. Go to the next slide. This was a sample that I got out of our soil 8 to 10 inches down. There was no hard pan. I just sort of want to take it from roughly the same area. And this one, it was super light. It didn't have the hard density like a rock. It was light and spongy, and it was actually so light, I was careful to carry it, afraid it would fall apart. And I'm thinking, I have to put this thing in water, and it's about to fall apart in my hands. Put it in the water, not one little nodule fell off. All of that is all the glomalin secreted by the biology holding all the aggregates together. Next slide.
So this is actually a very common test. I'm sorry to interrupt. It's an aggregate test that is often done of soil where they'll put it in water, and sometimes they'll put it in a screen at the top of a big, tall beaker. We didn't have that set up. And see how much is going to slough off versus how much is being held together, as Paul was just saying.
So in 5 minutes, that was the vineyard soil next door with low organic matter, no biology, no glomulins in there holding together. And this was the next day, 24 hours later, our soil. Still hadn't dropped a nodule off in 24 hours of just sitting in water. So lots of biology, lots of glomulin, lots of life in there.
And this came out of a bed that just the day prior we had cut out tomato plants that had been there for over 6 months.
Yep. Next.
Okay, so one of the ways that we keep plants in the ground, as often as possible, the next principle is that we'll do 3 to 8 sequential crops in the same bed throughout the course of 12 months. And so you can see every bed here is full. We got some bok choy, followed by some panisse lettuce, followed by some escarole, and so on and so forth. And when that bok choy is out, I can tell you the next day or a couple days later, we're gonna have the next crop in. And that is really important for us, both in terms of making money, because I wanna utilize that space to grow something else, but also in terms of feeding the soil.
Well, when the field manager's on it, it's the next hour. Next.
Grow as many different species as plants as practical. So I was sort of getting into this. So you're seeing more examples of, here's some peppers with some broccoli and fennel in between them. Next slide. Often what we will do is we will actually do multi-crops in here. So what you see here is a cauliflower. This is a Romanesco cauliflower that they're huge plants. So they have really wide spacing, 2 lines every 24 inches. Well, when you initially transplant little transplants into that soil, it looks like a lot of bare soil. So we utilize that space to put in a quick crop, in this case, a panisse lettuce. So here you have 100% cover of your Romanesco cauliflower, plus also a 66% cover of your lettuce, which you're going to harvest out just as the brassica is starting to close canopy. So you're getting 1.6 crops out of this, and you're feeding the soil, and you're retaining the moisture, and you're
suppressing weeds.
Thank you.
And the lettuce enjoys the light shade and windbreak from the brassicas. So all around you have better crops with less water, fewer weeds, and healthier soil with more root exits in the end. You've maximized your solar gain and solar capture. We also do that with things like leeks and mini romaines. There, the top picture actually has the leeks that were just transplanted with the mini romaine lettuces. If we're good, we'll get 3 crops of mini romaine lettuces out of our leek bed before the leeks harvest. If we're not so good, we'll get 2 crops of mini romaines. But to have 2 crops of mini romaines harvesting out for a few $1,000s in a 100-foot bed while the leeks are growing, and the mini romaines love it because they're getting the shade and the windbreak from the leeks. Meanwhile, they're suppressing weeds, and you're maximizing photosynthetic capture, which means you're maximizing root exudation, which means you're maximizing soil biology, health, and food. It's just a win-win-win. Other examples, tomatoes take a long time from transplant to first harvest. During that time period, we often get 2 shoulder crops of lettuces or other quick crops while the lettuce is growing. And by the time that second shoulder crop harvests, then the tomatoes begin harvesting. So another way to maximize return and maximize soil cover and root exudation, et cetera. We also this year tried a brand new style of doing with our brassicas. Brassicas aren't the best crop for your fungal colonies. They don't harm the fungal colonies, but they don't benefit them much either. It's a more mixed bag of results. And so we thought we have so much wonderful fungal activity in our soil. How do we bridge that during a brassica crop? How do we keep something feeding that fungal colony while the brassicas are in there? We began direct seeding fava beans into our broccoli crops. So you transplant a big old brassica and direct sow the fava bean at the same time. They co-grow together beautifully. Our soil was so much healthier at the end of the cycle. The crops were so much healthier during the growing of the cycle. And then as the fava beans get tall enough to begin shading, you just snip off the top 12 inches, bunch them together, and you have a wonderful fava bean tip harvest for restaurants, for farmers markets, for CSA, because these taste delicious. If you know fava beans, you know pea flavor to them, and then that whole green leaf has that same flavor. It's a really
We sold these for a lot of money to high-end restaurants. It was awesome, and we didn't cut down on our brassicas. In fact, we helped our brassicas.
Next. And next again, because the video. So, if it works.
Oh, please.
You can go back and try again.
So the idea of this is just showing lots of different crops in a space. It's in March, so we're just getting out our flush of late spring crops and early into summer crops. Okay, I guess it's not going to work.
Yeah, there's no volume on any of these. They're all just standard videos. So maybe it works, maybe not. No.
Oh well.
Okay, that's fine. And then, in addition to having crop diversity, that includes all of your perennials and your hedgerows and your non-direct economic crops as well. I mean, some of the hedgerow plants, like the biggest purple bush one up here, that's an elderberry, a medicinal elderberry that's native to Southern California and Baja California, and that bush alone gives us $200 of berries a year with no pruning, no watering, no fertilizing, no weeding, nothing, just harvest berries. So you can have plenty of other economic crops in your hedgerows, but it's so important to have the diversity in hedgerows around your fields for so many reasons. Next slide, I want to see if we... So here's just a tender perennial hedgerow in the front, the yellow flowers, next. Here's another hedgerow that's about 4 years old from establishment. You can see how close we put them to our fields. And honestly, we have these hedgerows scattered throughout all the fields, cutting in between fields and around the edge of the fields, and definitely on the upper wind sides to help block wind coming onto the farm. Next. This is a great picture that these are all plants that we established in the past 13 years, and yet to your left, about 20 feet, is a 140-acre conventional vineyard, and to your right, about 40 feet, is our field 11, one of our lower fields that we're growing organic veg in.
So these hedgerows are really super important in bringing in ecology, and we're going to talk about this a lot more in our workshop this afternoon because it's so important. Bringing in beneficial insects. We don't use any sprays on our farm, period. Not organic, not conventional, and partially because of our hedgerows and the beneficial insects that we raise in those and provide habitat for those, they are creating the balance with our pest insects that are out in the field. And
Try
also,
next again.
They're,
Even the roadways. This is peak dry season after 6 months of no rain, 7 months of no rain. And this is, the video's being really awkward on this pen drive. But those are the roadways that are unirrigated. Just keeping a diversity of clovers and perennial grasses in the roads is important, to not even forget about your roadways. But everywhere you have those roadways, those clovers, we've had a few herpetologists come out on our farm on farm tours, and they're supposed to walk around with us for an hour and a half, do a farm tour, and they end up flat on their bellies, staring in the clovers, looking at the myriad of beetles and spiders that are in there, who are all doing pest management for us and moving nutrients around. And it's amazing what can grow in the places that you think of just as your road that you travel on. Yeah. But to take care of it, not just have bare dirt always.
With the hedgerows, we often think about just the above ground insects, but one entomologist specifically, she's like, you see this beetle? He's going to walk 200 feet out into your field and eat this pest and this pest and this pest and this pest. I'm like, whoa, nice. You go, beetle.
Next.
Number 4, keep the soil covered all the time, and ideally with green photosynthesizing plants. Now, unlike a grass farmer, we are, cutting out the entire plants and then putting in the next plant, because that is our system. So we try and do that as much as possible, but we succeed a lot. Even if in the video, or the tried to be video from above, that there's lots of plants in that soil. Next. And we do this largely by focusing on having very healthy, very large transplants. And we'll talk about our nursery production more in our workshop this afternoon. We try to minimize what we direct seed so that when we take out, say, a broccoli, we're cutting out a photosynthesizing plant like this and putting in the next photosynthesizing plant like this instantaneously.
So those transplants are really critical to our operation. Yes, we direct seed, and we'll get into direct seeding definitely in our workshop this afternoon, but transplants, having big, healthy transplants, benefits the soil so much. It also benefits our growing conditions, because honestly, a big, healthy transplant spends more of its life in the nursery where it's really easy to manage, and less of its life out in the fields, which means if it's less time in the fields, that's more crops per year and less availability to pests. So we love our transplants for that reason. Plus, you got to think of your plants like your children. And when our children are born, we don't kick them out of the house on day 1. We actually keep them at home for the first quarter of their life. So our plants are pretty similar in that we can take care of them much better in a smaller confined area for that first quarter of their life before they move out into the big wide world.
In the nursery, haha.
Yeah. So more nursery pictures. Next, you can see the big size of the transplants. These are all transplants getting ready to go out. Some summer squash and eggplant in the back. Next. Transplants in the field. That's some baby bok choy heading down into the fields on our cart. These are lettuces going in, some summer squash, and this is another kale bed.
Toscano kale, yeah.
Next.
And when we do direct seed, we're also trying to keep the soil covered as much as possible. So what we do is after we'll seed them, and we direct seed like other farmers, we do more by hand because we really don't like having to rely on machines. We like relying on this and on this. So then we'll actually cover them with an agricultural burlap, which really helps with the germination, but also helps keep the soil covered until they really pop out of the soil, and then we'll actually cover it with another layer of a frost blanket.
Just as a reminder, even that week or 2 of trying to germinate a seed in bare soil, that bare soil is getting hot in the daytime, cold at night. The biology in the soil, all the living organisms that we're trying to encourage to help grow our food with us and for us, they don't like hot soil, cold soil, hot soil, cold soil. They don't like full exposure to wind and sun. They're going to go down deeper in the soil to escape that, so the top inches become devoid of life. And honestly, they can't really go deeper because there's already biology there. So really, you're just eliminating habitable space in your soil for the biology. So you really want to keep that soil covered and protected to really take care of the biology in it. And it's amazing what comes out from covers like this or covers like the next one we'll see. Next slide. That you just end up pulling off a cover like this, and you have chocolate cake underneath. You have this gorgeous, dark soil that has had so much biological activity in it. And this kind of cover with a permeable plastic, we like a permeable breathing plastic, so we don't want to solarize, but we do this only as a last resort of covering. If we can't do direct seeded crops or a transplanted crop and it's dead of winter like December, and it's too dark and too short a day length to actually transplant at the time of year, then we will cover the beds like this and basically put them to rest like a blanket for winter until we are ready to use the beds by late January when there's enough day length that we can actually get transplants in really early. But if these beds lay at rest like this for 6 weeks, then you uncover them, that soil is gorgeous and healthy, and it wasn't solarized, but it is warmed up by that black covering, so you actually have more biological activity happening, getting your soil ready for the next crop going in.
And we know a lot of farmers who are in much colder climates than we are, like 6,000 feet in Colorado and Nova Scotia, and they utilize this a lot more for their winter. Yep. It also, the warming of the soil factor is even more important for them.
Yep.
Next.
That's just a standard landscape fabric. It's a woven plastic. I don't have a name for it. I've asked repeatedly, and all they give me is the distributor's name. If you want to call Harmony Farm Supply in Sebastopol, it's part number 48104.
It's also a technique. It's a technique that's called occultation, tarping. Some people use silage tarps. It's pretty common among bio-intensive farming.
Yeah, this stuff comes in 3 foot, 6 foot, 9 foot, 12 foot widths, so they're very easy to work with, even for some of our 5 foot employees by themselves out there, rather than a big silage tarp.
So now the fifth principle is something that we didn't actually talk about for the first several years, and partially because we're like, oh, we don't have animals, and we definitely see the import of, big herds coming through an area, and when we're doing intensive vegetable production, we can't exactly have that, or, we tried with chickens and ducks and various different things. And then I was talking to Dee Dee Perhouse, and she's like, what are you talking about? You're incorporating animals everywhere, all around. No, they're not bison, they're not, sheep and so forth. Although we do have sheep around the perimeter to help us manage some of our area that we can't farm.
And chickens and ducks.
And chickens and ducks and so forth. But we like to think outside, the major livestock box. So these hedgerows, they're helping promote, I talked about the beneficial insects, but also they're phenomenal habitat for snakes, for birds. We've seen our bird life on our farm go crazy. So these are some of the animals that we are incorporating in our fields. And honestly, also by having those hedgerows and increasing the ecology, we also have larger animals. We have a lot of gophers, which I loved the idea of selling gophers as pets. But we also have bobcats on our property. We lost a couple of sheep to a mountain lion. So we are very sort of peri-urban, but also being contiguous with a riparian corridor and then continuing that on our farm is lovely to have lots of animals, both small and large, on our property.
And don't forget, there's about 3,000 species of native bees in the US, in North America, and about 1,900 of those species are native to California, and 85–90% of those native bee species are ground nesting. They need undisturbed soil without tillage to survive. And what are they doing for us? They're helping pollinate our crops and doing some pest management, honestly.
In fact, they're much better pollinators than honeybees. Much.
Next. Miguel is our one monolingual Spanish speaker from Mexico employee who's been with us 6 years full time. He's awesome, but like many of his brethren from Mexico, he was terrified of snakes when he first came to our farm. He wouldn't even go within 100 feet of one that we were holding or that we saw. He'd want to bug out. But one of his jobs over the 6 years grew to become pest management. So he was working on the gopher traps and the mouse traps out in the fields, sort of mechanical control to trap them out. And we explained to him what the benefit of snakes are, and in fact, we explained hedgerows and why we have hedgerows, and in part is to encourage snakes, to help us encourage pest control through snakes. When he learned that, he slowly got to the point where that's a giant grin on his face because he knows those are mis compañeros, those are his helpers and his friends, and he will move the snakes around the farm according to where there's the highest rodent populations to really have them work for us and for him. So it's quite amazing how he's transcended to a place where he understands the natural cycle and natural pest management. That was a gopher snake. We have gopher snakes, garter snakes, yellow-bellied racers. Nothing poisonous, but we do have friends who are farming areas with rattlesnakes, etc.
Yeah, Kern Family Farm has rattlesnakes, and they keep them on their property on purpose. So, this is just showing hedgerows in winter next to fields. But let's keep going. Also, incorporating animals. What do you think goes in here? Manure. And like I said, we don't have a lot of animals on our property, but we have good relationships with a chicken farmer and with someone who boards horse and with someone who has sheep. So we will bring in the manure and add it to our compost, and that is really important.
From organically fed horses and sheep, etc.
We do have a good relationship with them and know how they treat their animals and even where they get their feed sources from. But that makes up about 20% of our compost and a very important part of it.
Oh, this is just a transition slide to the next section. Had to include it. One of our helpers out there in the field doing some pest control for us on a new hoop house that we're constructing right after a rainstorm. But I do love this quote. And I think it's critical to remember. And I think remembering this quote in the idea of both above ground ecology with your perennials mixed in with your annuals, and but non-crops with your crops, as well as the below ground ecology that we often don't see unless you pull out a microscope or go to a lab, et cetera. But it's so important to remember, the more life you can have, the more it helps sustain more life. It's a self-reinforcing, virtuous cycle. Everything just gets better and better and better the more life you can have in a system.
So we're going to talk real quickly about sort of the meat and potatoes of how we do our field management. We're going to talk about transitioning a bed, and we're going to go through these steps here. I'm not going to read them here. I'll read them as we go through them next. So the first thing we're going to do, if we're going to clear a bed, this was some Siberian kale, and even though it was flowering, we were still harvesting from it. It tasted great. So we didn't want to harvest it out at that time. We didn't want to harvest it when it started flowering because it was still very productive for us. But at this point, we were ready for it. So you can see Marty here, he's got some loppers, and he's cutting those plants out at the soil level. We don't want to pull those out because all of those roots, those have got the rhizosphere. That is going to be our densest area of microbiology in the soil. So we want to leave that intact and the soil intact as much as possible. So we're going to cut that off at or just below soil surface.
90% of our crops we remove, we use a harvest knife for. Only 10% of the overwintering brassicas with the big stems we'll use the loppers on, but usually it's just a harvest knife going in to cut out.
So now this is not all the time. As you can see, it's only as needed. Lift pathways onto bed, broad fork, and rake. So you can see Sam here working with a broad fork. A broad fork we see at this point as a transition tool. And as we worked away from tillage, at first we were doing tractor tillage, then rototiller, then a tilther, then we started using a broad fork. Honestly, on about 70% of our fields, they haven't seen a broad fork in 5 years at this point. But our lower fields that are more clay-based and that get flooded almost every winter, which is where we are in this slide here, we will use a broad fork about once a year. So it's not inverting the soil, but it's just opening it up and loosening it. And
decompacting in our flood zone.
Yeah. Absolutely. We love the Johnny's broad fork, partially because it's got the wooden handles and it's not quite so heavy. So your biggest work in using this is lifting it each time. So that's broad forking.
Lifting pathways is about scooping out all the biomass that collects in your pathways over the years and putting it back on the bed. And we'll usually lift a pathway every 2 or 3 years. So we'll have 15 or 20 crops happening in the beds between the times we lift a pathway. Because pathways is going to collect biomass. So what it's doing is it's collecting beautiful topsoil for you. Every once in a while, just scoop it out, put it back on the bed, and reform a nice big wide bed. The raking out is really just to rake that bed nice wide and get a big planting surface on it. So all three of these things, we rarely do, but they are useful at times. Next. This is the main meat and potatoes. Once you cut out the crop, leave the roots intact, put all the top growth into the compost pile, come back, put down organic fertilizers if you need them, put down compost if you need them. These beds went from an overwintering 6-month brassica crop to what's going to be tomato crop for another 6 months. So there was 2 very long duration heavy feeder crops. So in this case, they got about a 1/2 inch of compost. It looks like more because of the contrast, but it was 3 wheelbarrows for about 100-foot or 95-foot beds. So it was about a 1/2 inch of compost at the most. And then got some organic feather meal, which is just a nitrogen source, and calcium, because calcium is pretty much always good in most soils. Next.
As needed, meaning only about 60% of our bed, our transitions will get those fertilizers.
Yeah. Frequently
and about
we'll do,
80% get compost.
Yeah, frequently we'll do an amendment for a cucumber crop, and when the cucs come out, we'll put in 3 sequential lettuce crops with no further amendments. We'll get 4 crops in a row off of 1 amendment application. So transplants, they go in, next, right away. Next slide. Watering in by hand, just to get them settled in, get the compost settled in, the transplants and the roots settled in, get that soil moistened for the biology to keep it active and healthy. Cover them as needed, whether it's covering for frost and birds and deer. Next. Here's more coverings, different kinds. Next. And this video better work. So here's an example of doing 4 beds that are 85 foot long each, and it's 3 people, and it was 45 minutes. It's actually all written down below where it got cut off. But it's 4 beds, 45 minutes, 3 people. So they cleared the beds, moved all the biomass, took the irrigation lines off, put down calcium and feather meal, put down compost. You'll see it's about 3 wheelbarrows or 2.5 wheelbarrows per bed, and that's it. And we use the tractor to help move compost around the farm. It's just more efficient for us. It's the only use it has. It's a lot of work doing all this transplanting, especially when it goes rain, dry, so you gotta have a coffee break once in a while. Then you get back to work, keep going, and as some people, you can see it's actually a multi-crop here. We're doing the Romanesco cauliflower intercropped with lettuces, so we have that 1.7 crops per bed, and they're gonna co-benefit and help keep the soil covered and protected. Come on, video. Come on, computer. And just getting stuck over there. We've never had that issue before. Okay. And
you guys got the idea, I
you
think.
got the idea of that. So, not the good ending, but hey.
So what we're happening is the carbon and biology that happened from these crops up here is really feeding the next crops. And actually, I'm going to pose an interesting question of, notice the crops that came out and notice the crops that went back in. What's the commonality?
Brassicas followed by brassicas.
So crop rotation, over the course of 3 to 8 crops in a bed, and often many of those, like these down here, being multi-crops, we will get a lot of rotation. Having a really positive biology in our soil, we don't worry about it that much. We have neighboring farmers who tell us about, how do you manage keeping track of where you have a brassica? Because if I have a brassica in an area, I can't put another brassica in there again for 2 years because of diseases that build up in the soil. We haven't had that problem as soon as we got our soil organic matter up higher because we've got biology in the soil helping manage those. And we've got different brassicas going in. This one has a multi-crop in it. So there is inherently in the system a lot of different crops going in and out, each one feeding the soil different nutrients, also depending upon the time of year that they're in there. But we don't have to worry about it as much. Going back to what I said, you get your soil organic matter and your biology in that healthy range where Mother Nature intended it, and growing plants is just a lot easier.
One more important observation too is the top picture. The beds are fairly weed-free, and usually we have a few weeds here and there when we clear the bed, but those beds were never weeded to become weed-free. That's through a process of being intensive and always transitioning rapidly, never letting a crop that has expired and you've harvested to sit there for a week or two, because once you've harvested the broccoli cauliflower and you let the plant sit a few weeks, that's when the increasers come in. All the weeds come in and fill in underneath your broccoli crop. So you've got to make sure that when the harvest is done that morning, come back later that morning or afternoon, clear that bed, put the next crop in, and you basically end up suppressing weeds through being intensive and a rapid turnover, so that clearing the beds, I mean, those are weed-free, and they were never weeded to get to that point. Next.
Most of you actually probably can't see this. Tenets of sort of how we work on our farm. The first one is no tillage of any sort. The second one is be very intensive. And the third one is really focus on ecology. And what we find is that these 3 things really cycle into helping each other. We're intensive, we don't let the weeds come in, and we get new, young photosynthesizing plants in the ground to help with the ecology. We have ecology to help with our pest management, so we don't have to use any sprays, so that we aren't killing the biology in our soil. We're no-till, and we're not destroying any of the carbon, we're not releasing the carbon in the soil and decreasing our soil organic matter, and we're not killing the life in our soil. So we feel that these 3 aspects are really important within the whole system.
And one more aspect of pest control that we haven't mentioned is, honestly, if you have really healthy soil biology, nearly every pest insect out there has a life cycle stage in the soil. We talked to soil scientists about this, and they totally agree. If you've got that adult insect that drops off the leaf, burrows into the ground to lay its eggs hatch, become pupa or larvae, come out of the ground to become adults and feed on your crop again, when your biology is really up there and you have really strong, healthy soil biology, that adult that goes in the ground may never even survive long enough to lay eggs. And if it does lay eggs, boy, those eggs are gone in a heartbeat. So a massive amount of pest control simply comes from having biology in the soil to devour the pests so they never make the next generation of pests. Next.
Okay, this comes from a report that I really like, and it's cut off, but it's from the ETC group, and it's an international group that looked at, what do we need in terms of feeding the world, really, and most of what they came to is that small shareholders are what we need. Now, there's different definitions of what small shareholders are depending upon, the types of crop that there are and everything. I'm going to read this, and then this infographic was put together by another organization called Growing Culture. I'm going to read this from the bottom because I think it's really important. So on one side, they look at the industrial food chain, and the other side, small shareholders, which the ETC actually calls peasant farmers. So I'm a peasant farmer. Yeah. So peasant farmers produce 70% of the world's food. Now, this is hard for us in the United States because we see so many large operations. And I loved what Laura said earlier about not being able to find a small combine and in the United States, only outside of the United States. I think that really sort of illustrates how we are lacking in small producers, and yet small is beautiful. So 70% of the world's food is produced by small shareholders versus 30% by the industrial. Then look at the natural resources used. Only 20% over here for the peasant farmers versus 80% over there. You guys can get this.
Oops.
Calories consumed. So calories obtained for calories expended. I really like this because I think that it shows how sustainable a system is. You know, what are you putting in and what calories are you putting in? Are they petrochemical calories? So over here, the peasant food web is getting out 15 calories for every calorie expended, versus on the other side, 1 to 1.5.
150% ROI might not seem bad, but when you compare it to a 1,500% ROI, that's where I'm going.
Then other stats as well. On the one side in the industrial food chain, only 20% of the farmers being women, almost double on this side. Now look at the number of varieties. You're looking at all those patented varieties and not very many up there, 80,000 versus over 2 million. So I love thinking about it in this sense. We need more small-scale farmers. We need more really family farmers, and I think that's been a lot of the discussion of today. So I very much appreciate that.
And because this is always brought up and it's important to talk about, even though our main focus is the ecology and the community and the social and agricultural aspects, you also have to be sustainable economically. Otherwise, you're not going to be there next year. You can't just be a beautiful farm and fail every year over and over again. So it's important to look at what kinds of revenues, gross revenues we have coming in from different aspects of economy. These are all California Department of Food and Ag stats, the first ones.
We're comparing to our neighbors, so sorry, these are all California numbers.
Yeah, these are all California numbers. So California Department of Food and Ag, those numbers seem incredibly low for big industrial ag, but that's kind of what it is. Really, you get into the California Diversified Direct Market Vegetable Farms, mainly organic, they're at 11,000. Again, PowerPoint.
This is gross revenue
per acre per year.
Acre per year.
And Sonoma County vineyards are about 11,000 gross revenue per crop acre per year, which we talked to our vineyard friends, they're like, yeah, you know, the good vineyards might get 20, but most of us are sort of 8 to 12. And then you have economic viability. This was detailed in a report by one of the UC Davis professors, Ryan Galt, who looked into organic farms and CSA farms in California. And it's just over $14,000 per crop acre per year as gross, really is sort of the bare minimum to be economically viable. And we've seen that with many of our friends and many other farms we know, that they're definitely doing that 18 to 25,000 per acre per year, which is great, they're doing awesome. And the ones who are doing less are really struggling, and we see that, unfortunately. And for example, there's 2 different local ag schools that have farms, and they're both doing over that minimum, which is good. So our local Santa Rosa Junior College, they're actually one of the premier junior college organic farms in the nation, and they're doing a great job. They've got their 30, 40 acres they've been doing for about 40 years organically, and they do a great job. UC Davis Students Farm, that's about 3 acres, also doing about 17.5 per acre per year as gross. And then we're up there
Go back
a little bit.
So part of this is us, but there are a lot of people replicating at this point. So this is not to give us a big pat on the shoulder. No. Part of this is also sort of the continuum of what we were just talking about. You know, the industrial farms, and you know, they're using a lot of space and a lot of resources to produce not very much. And as you get down to more, you know, your farmers that you're seeing at the farmers markets, you're increasing that. And as you get into a super intensive system, you're able to do the 100,000. The farm that I showed the soil of, and I said this field hasn't even been in production for a year, they're doing well over 100,000. They're more like 140 this past year of 2018. So it's absolutely feasible. You just need to take care of your soil. And now we know that this is gross and that net is very important. So the next slide, we do need to talk about our net. So if we look at our gross at Singing Frogs Farm of being 100,000 per acre, the net, we really consider all of this the net because, you know...
we love investing in people, not machinery and diesel fuel, but people. So to us, that's an awesome place to put 80 cents on the dollar of every dollar coming in back into our people, our community, and ourselves. That's a great place to put our money, and we love that.
Yep. So next slide. So this is where our net really is going in all of our people. And we have a lovely lovely crew. We've got about 4 people that are full-time, and then lots of part-timers that come in and about.
And honestly, this is still not an accurate crew photo because we can never get everyone on the farm at the same time, but there's usually whatever crew photo we have, add 3 or 4 people to it, and that's really the full crew. And this is also early last year or late last year. So anyway, next.
So what we really want to see is we want to see more people replicating this, and it's really fun to be here and be sharing with you for that reason. I don't even know all the people who are making this work. Mossy Willow Farm, they're really fantastic. Follow them on social media if you want to see some pretty pictures, and especially if you want to salivate over things like tomatoes right now, because they're outside of Melbourne, Australia, and they're just hitting tomato season right now. They worked on our farm for about a year before they started that farm right there. 10 Mothers Farm is in Virginia. 2 Roots is near Aspen, Colorado. Spoonful Farm is up in Washington. Nye Ranch is up in our neck of the woods, up on the Mendocino coast. Woven Roots is in Massachusetts. Terra Vita Farm is in Durango, Colorado. Hillview is the one that I just mentioned with their gross revenue. Then we've done some work with the Center for No-Till Agriculture in Ghana, which has been a lot of fun. And then our friend and neighbor, Katie Hackmeyer of Red H Farm.
And this slide used to be 1 or 2 farm names, and right now actually we could have about 5 or 7 slides up here with 10 or 12 names each of people around the world putting what we have into practice and making it work as well or better than we're making it work. I sometimes think that we're really good at the ecology part. We're not actually the best farmers, but we have figured out a system that works very well for us, and others who are even better farmers have taken it even further. Tierra Vita Farm is a great example of somebody who had never farmed before, but he was working with a food-oriented nonprofit, and he kept bumping into us, and he'd bring farm tours out to us, and he brought me out to Colorado to give a tour, and he got so enthused by what we were doing, he didn't want to be in the nonprofit world anymore. He wanted to actually do it himself, get his hands in the dirt. And he's been doing, at 7,000 feet elevation outside Durango, he's been doing a year-round CSA on his small intensive market garden and bringing in the same kind of revenue we are in Durango. So
Next. We do workshops, and as was said, actually several people here have had workshops. If you come out through our area, let us know. We love to have people visit the farm. If you can make a workshop, that's awesome, because we'll get our hands in the soil and dig around and see how we transition over beds. But overall, we just have a lot of fun. So these are all from workshops. And then see if this works. Play.
come on, video.
Nope. Okay. Anyway, thank you all very much for having us.
And that was great. We'll see you in our workshop this afternoon. Thank you.